Keeper 4.3, the Maclaurin series. Alright, so this is your general form of your Maclaurin series. Notice that your Maclaurin series is always going to have a 0 in it. In other words, it's always going to be centered at 0. It's not going to be like x minus 5 or x plus 2. It's always just going to be x. Also notice that this, where it says f to the n, and the n is in parentheses, anytime you see n in parentheses like that, that's not a power of n, it's the derivative of n. So again, it's like f, the first derivative of f, or the second derivative of f, or the third derivative of f. But that's a derivative, not a power. The other thing you guys need to know is that this needs to be this general form of this Maclaurin series. You need to know it. You need to know it's your derivative over your factorial times x to whatever function, whatever number you're on. All right, so like if I'm on the second n, then x would be, or n would be 2. All right, so example 1, it says find the Maclaurin series for f of x equals e to the x, then find the radius and interval of convergence. F of x equals e to the x is actually a common Maclaurin series that we will end up having to memorize in the end. I'm just going to show you guys how to derive it so that you guys know where it comes from. And so what I'm going to do is I'm going to start by taking my derivatives. I'm just going to take a bunch of them, and I'm going to center it, or I'm going to take that derivative at x equals 0. Since it's a Maclaurin series, I know the center is 0. All right, so like I'm going to start with my original function of f of x, and then I'm going to plug in 0 to that. I get 1. Then I'm going to take the derivative of that function, and I get e to the x again, and the derivative of that at 0 is 1. And then I'm going to do the second derivative, which is e to the x, and then the second derivative at 0 is 1. And I'm going to keep going. I mean, obviously I see that there's a pattern here. It's always going to give me 1. Generally, when I build my series, I try to go out at least to the fourth derivative. Sometimes I go a little bit further depending on what the function is. Alright, so now that I have all my derivatives written out, I'm going to build my series, and I'm using that formula of the Maclaurin series from the previous slide. So I'm going to start with 1 because that's my first function, so or my original function, so I'm starting with 1. And so this one right here is this one down here. Alright, so then the next one I'm going to do 1 times x over technically 1 factorial, but again this one is simply this one of the first derivative. Alright, so the next one, again, the one out front, the 1 times x squared over 2 factorial, the one in front is the one from the derivative. And then using the formula for the Maclaurin series, it says now you're going to have x squared over 2 factorial. And I'm going to continue that on, so I'd have like 1 times x cubed over 3 factorial, 1 times x to the 4th over 4 factorial, and so on, all the way till I get to 1 times x to the n over n factorial. Again, this 1 in front is coming from the derivative. And so now that I have my series built and I see the pattern, I could write it as a summation. So I have the sum as n goes from 0 to infinity of x to the n over n factorial. Alright, so now we have to find the interval of convergence in the radius. And so again, I'm taking my series. Remember, to find your radius and interval, the easiest way is just to simply do your ratio test. And so I'm doing the ratio test. And when I simplify this ratio test out, I get x over n plus 1. Now when I plug in infinity, I'm going to get 0, and 0 is less than 1, which means that it converges absolutely. And because it converges absolutely, my radius is going to be infinity, and my interval is going to go from negative infinity to infinity. Alright, so example 2, we have f of x equals cosine x. Again, this is one that you're actually going to end up having to memorize. But I'm going to build it for you guys so you can see where it comes from. Alright, so again, I'm going to start by taking a few derivatives at x equals 0. So I'm going to start with the original function at 0 is 1. The derivative of that function at 0 is 0. The second derivative of the function is negative cosine x, and at 0 is negative 1. And I'm just going to continue that on, taking all the way till I get at least 3 solid numbers on that right hand side. So again, a lot of times that goes to the 4th derivative. Sometimes you might have to even go to the 5th derivative, just depending on the function that you have. Alright, so once you write out your a few of your derivatives, you're going to build your series. So again, using that formula for the Maclaurin series, I'm going to start with the first value, which was 1. and then I'm going to do 0 times x, and then negative 1 times x squared over 2 factorial, plus 0 times x cubed over 3 factorial, plus 1 times x to the fourth over 4 factorial. Again, remember that these coefficients that I'm writing for my series is coming from the derivatives that I found in the previous step. The rest of it is just the general form of your Maclaurin series. All right, so now that I have that written out, I'm going to clean it up and I'm going to get rid of all of those 0 terms. So if you notice, all of the 0 terms are odd, like x cubed or x to the first or x to the fifth. And so all I'm left with for cosine of x is 1 minus x squared over 2 factorial plus x to the fourth over 4 factorial. Notice that all of these numbers I have left, all of my exponents and my factorials are even. Also notice that I'm alternating signs back and forth between positive and negative. And so what I noticed is the pattern is negative 1 to the n, and I had to include that again for the sign alteration. And then I have x to the 2n. I'm using 2n because my exponents are even, all over 2n factorial again because my factorials are even. And so then I can write that as a summation as n goes from 0 to infinity of negative 1 to the n, x to the 2n over 2n factorial. Again, this is a series you need to know. You need to have this, you need to write this down and memorize it. All right, now if I want to find the interval and radius of convergence, I'm simply going to do my ratio test. And so when I do my ratio test, again, I add 1. Make sure when you add 1 to the n that you distribute. So like our original function was 2 to the n, and when I do 2 to the n plus 1, it's really going to come out to be 2 to the n plus 2 because I have to distribute. And so I write out my ratio test and I simplify what I can, and what I'm left with is x squared over 2n plus 2 times 2n plus 1. All right, so when I plug in infinity for my n to find the limit, I get 0. 0 is less than 1, which tells me that this converges absolutely. So again, my radius is infinity, and my interval is going to go from negative infinity to infinity. All right, so here's another example of one that you actually are going to end up having to memorize. But again, just to build it so you guys can kind of see where it's coming from. Now, I'm not going to build every single one that you have to memorize. I'm just showing you a couple just so you can see, like, if you forgot what it was, you can still build it out. So again, I'm going to start with my derivatives at 0. So starting with the first function or the original function, sine of 0 is 0. The derivative is cosine, so cosine of 0 is 1. And then the derivative of that is negative sine, and negative sine of 0 is 0. And I'm just going to keep that going. This time I'm going to go all the way to the fifth derivative just so I have enough numbers to actually see a pattern. All right, being that we started with 0. All right, so now I'm going to build my series using my Maclaurin formula. So I have sine of x is 0 plus 1x plus 0x squared over 2 factorial minus 1 over x cubed over 3 factorial and so on. Noticing that those coefficients are coming from my derivatives. Now if I simplify this and get rid of all of my 0 terms, you notice that all of your even terms, or your squares and your fourths and your sixths, they're going to cancel out, and you're simply going to be left with your odd terms. And so also notice that your signs are still alternating between positive 1 or negative 1, positive, negative, positive, negative. And so when you write this out, you need to include that sign change by doing the negative 1 to the n, and then I have x to the 2n plus 1 to account for the odds over 2n plus 1 again to account for the odds on my factorial. And so my summation, my final summation, is going to be the sum from n equals 0 to infinity of negative 1 to the n times x to the 2n plus 1 over 2n plus 1 factorial. Now, if I want to find the radius in the interval of convergence, again, I'm going to use that ratio test. And so I'm going to start with my summation that I built or that I wrote. I'm going to do the ratio test on it, making sure that I distribute my my coefficients when I do the x plus 1 or the n plus 1 part. And then I'm going to simplify that, and I'm going to be left with x squared over 2n plus 3 over 2n plus 2. And so when I take the limit of that, I get 0. 0 is less than 1. And so it converges absolutely, giving us a radius of infinity and an interval of negative infinity to infinity. Now again, as I've been saying, you need to memorize some of these Maclaurin series, because what's going to happen is if you have them memorized, you could just use the memorize what you memorize to build other series. And so your goal for tonight is to go home and, I don't know, make some flashcards, memorize these series, and I'm going to give you a few more. Now again, these ones that I'm giving you, we can build them out. I'm just not going to build all of them. I'm just going to ask you guys to memorize them, and if you want to see one built, I can definitely build one for you, of the ones that we haven't talked about. So the 7 series that you need to memorize, we have 1 over 1 minus x, which we already talked about. That's the sum as n goes from 0 to infinity of x to the n. And I also want you guys to memorize 1 over 1 plus x, which is just negative 1 to the n, x to the n. E to the x, which we just did in this lesson, which would be the sum as n goes from 0 to infinity of x to the n over n factorial. And then I also want you guys to know ln of 1 plus x, which is the sum as n equals 0 to infinity of negative 1 to the n, x to the n plus 1 over n plus 1. All right, 3 more that I need you guys to memorize would be sine of x, which we did earlier, negative 1 to the n, x to the 2n plus 1 over 2n plus 1 factorial. Cosine x, which we built earlier, negative 1 to the n, x to the 2n over 2n factorial. And I also want you to know tan inverse of x, which would be negative 1 to the n, x to the 2n plus 1 over 2n plus 1. Now, remember, I need these memorized. You will have a quiz on these functions. I'm just recalling these functions. It will be a time quiz to make sure you actually know them and are not trying to build them.